This is for Algebra 2. This is logs and log functions, day 2. Remember that logarithmic form is x equal log base 10 of y. An exponential form would be y is equal 10 to the x. Keep in mind that your base is what holds the exponent for exponential. It is what is written down low as a subscript in logarithmic. Your exponent is what's up high in the exponential, and it is the number that's by itself in logarithmic. If they do not write a base, if it just says x is equal to log of y, when there is not a base down there, then your base is 10. The calculator has a log button. If you ever use it, it just automatically goes with base 10. So going back and forth, this is just kind of remembering from yesterday, to change it from logarithmic to exponential, your base becomes the base, right? So your base is now holding the exponent. And then basically what happens is these two are going to swap places. So it becomes y is equal to 10 to the x. You could have also written that 10 to the x is equal to y. Same difference. So if 4 is equal to log base 10 of 10,000, your base is now 10 and your exponent is 4. So 10 to the 4th is equal to 10,000. So when you look here, your base is what's holding the exponent. So 10 is your base, and then the 1,000 and the 3 have to swap sides. And so this is going to become 3 is equal to log base 10 of 1,000, or log base 10 of 1,000 equals 3. It doesn't matter which one is on left and which one is on right. Log base 2 of 16 equals 4 becomes 2 to the 4th equals 16. 3 squared equals 9 means log base 3 of 9 equals 2. Negative 3 equals log base 3 of 1 over 27 becomes 3 to the negative 3 equals 1 over 27. 3 to the negative 4 equals 1 over 81 becomes log base 3 of 1 over 81 equals negative 4. So your base is always your base, and then you just have to swap sides for the other two. So if you're going to solve logarithmic equations, the first thing you need to do is change it to exponential form. Then you think back to what we did earlier, and you get to the same base on both sides, and set your exponents equal to each other and solve. Remember that anything to the 0 power equals 1. So number 1, log base 10 of 100 is equal to x. We rewrite it and it becomes 10 to the x power equals 100. Sometimes you can look at this and you'll just know. 10 to what power is 100? Well, that would be 10 squared. So 10 to the x is equal to 10 squared, and so x is 2. Log base 10 of the square root of 10 becomes 10 to the x equals the square root of 10. And if it confuses you, think of this as being equals x. So 10 to the x equals square root of 10. Well, we know that the square root of 10 can be rewritten as 10 to the 1/2. So 10 to the x is equal to 10 to the 1/2. Set your exponents equal. X is equal to 1/2. Log base 2 of 8, if it helps you, put equals x. You will rewrite this. 2 to the x is equal to 8. 2 to what power is 8? And it's 3. If you can just tell without showing this, I'm okay with it. But you've got to give me a little bit of work. Log base b of 1. Okay, so b to the first, or b to the x is equal to 1. Anything to the 0 power equals 1, so x is 0. This will become 10 to the x is equal to 0.001. This has to be a base of 10, and it would be 10 to the negative 3, so x is negative 3. Okay, so there's not a back on your notes, but I want you to turn it over and work some of these problems. If I were to rewrite this, this would be log base 16 of 2 is equal to x. My base is still my base, and my x and my 2 swap sides. So now we're going to match up. If we had log base 8 of 32 is equal to 5/3, this becomes 8 to the 5/3 equals 32. This is going to not have a base. Remember, if there's not a base, it's 10. So 10 to the negative 2 equals 0.01. m to the w equals z. This has to be rewritten with the log. Your base has to be 5, and then you're going to swap. So log base 5 is 625 is equal to 4. This is going to be log base 9 of 1/3 is equal to negative 1/2. And then log base p of r is equal to k. So if you were to solve this, you would say this is a base 10. So 10 to the negative 2 is equal to x. And then you would use your calculator and you would say 10 rooftop negative 2 and x is equal to 0.01. You would say x to the 4th is equal to 5.0625. Remember that when it's something we can't look at and just tell, you would rooftop that to the 1 divided by 4. Okay? It's divided by 4 because it's the 4th power. So we have 5.0625 rooftop open 1 divided by 4, and we get 1.5. X is equal to 1.5. This becomes x to the 1/3 is equal to 4. You would want to rewrite this. This is the cubed root of x is equal to 4, so we're going to cube both sides. X is equal to 64. 8 to the 3rd is equal to x. If you weren't sure, you would take your calculator. 8 rooftop 3, 512 is equal to x. 6 to the x is equal to 216. You could trial and error it. We know it's not squared, so what's 6 to the 3rd? There it is. X is equal to 3. 9 to the x is equal to 1/81. Well, we need to realize it's in the bottom, so it's a negative, and 9 squared is 181, so x is equal to negative 2. All right, you don't have to write this down, but I do want to work through it. Graph the following logarithmic equation. First of all, rewrite it as exponential. Then complete the table, plot the points, and connect them. So we're going to start by rewriting it. You do not have to write it down, but I do want you to take the time and watch it because you need to know this. When we rewrite it, it becomes y minus 2 is equal to log base 3 of x minus 1. We moved this 2 here. So then we're going to have to rewrite it. 3 to the y minus 2 is equal to x minus 1. So now we're going to add 1, and you get 1 plus 3 to the y minus 2 is equal to x. Okay, so then if you put 1 in for y, you get 1.3. If you put 2 in for y, you get 2. If you put 3 in for y, you get 4. This is just putting it into this equation here. 4 gives you 10, 5 gives you 28, and 6 gives you 82. If you plotted those points, you would have an exponential curve. All right, that takes you to your assignment. If you have any questions, come find me or call me over.